Hi everyone, in today's lesson we're going to talk about our last day of trinomials. So today we'll call factoring trinomials day 3. And in today's lesson we're going to talk about things called higher order trinomials. So what exactly is a higher order trinomial? Well, a higher order trinomial is a polynomial with a degree or an exponent. Degree is the same thing as exponent. With a degree or exponent higher than, greater than, higher than 2. So let's just take a look at the first two examples that I have here. Look at this trinomial. It has an exponent of 4, and this one has an exponent of 9. So these are definitely not the types of trinomials that we're used to, but the way that we factor them is going to be the same. So in the first example, we're going to do it just like we normally did. So we have a to the fourth times negative 24. We're multiplying those. So we have negative 24 a to the fourth power. So let's go ahead and find our factors. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We need to multiply actually to a negative 24, so I'm going to go ahead and make the first terms negative, right? Because we need negative and a positive. But now this time we have to multiply to a higher power. So we have to multiply to a to the fourth. So how do we do that? We're just going to make this a squared and a squared. And now we'll be able to find which pair on this list is going to add to my middle term of negative 2a squared. So let's look at here. So we have 1 and 24, that's not going to work. 2 and 12, too far apart. 3 and 8, no. This one might be it. Negative 4a squared plus 6a squared. That actually adds to a positive 2. So I think if I just switch them, so if I make this a positive 4a squared and a negative 6a squared, and I just add one more list, this pair will add to my negative 2a squared. So we bring down our first term like normal. We bring down our last term. And we fill the middle with the pair that adds. So we have 4a squared and negative 6a squared. And just like we've always been doing, we're going to factor by grouping. Group the first two, group the second two, and bring down the sign in the middle. So my GCF for the first two is a squared. And if I divide a to the fourth by a squared, I get a squared. And when I divide 4a squared by a squared, the a squareds cancel. So I'm just left with plus 4. And my second two terms, my GCF is going to be a negative 3. Negative 6 is my largest factor. And when I divide them, I'm going to get a squared plus 4. And now my parentheses are the same. So that's going to be my last step. So a squared plus 4 is my GCF. And when I divide this term by a squared plus 4, I get that. When I divide this term by this, I get that. So my last parenthesis is going to be a squared minus 6. And that is my final answer. Awesome. Now, notice the structure of these trinomials. This has a power of 4, so the middle should have half of the power, which it does, 2. And there's no variable on this side, so there's nothing that needs to be halved. Okay, awesome. Let's look at number 2, and let's look at the structure. This has a b to the 9th power, but this has a b to the 5th. It's supposed to be half, but I can't take half of 9. It's going to be like 4.5. And b and half of this structure is really no good. So this kind of leads me to believe that there might be a GCF that I can take out first. So if I analyze this, it looks like there's a 2, a 6, and a 56. They're all even. So I'm definitely going to be able to take out a 2. But now I have a b to the 9th, a b to the 5th, and a b here. So I actually think I can take out a 2 and a b. So I'm going to go ahead and divide each piece by 2b. So I take the 2b followed by an open parenthesis. First term, these cancel. When I divide the b's, I subtract the powers, so I get b to the 8th. In the middle, 6 divided by 2 is 3. Keep the base, subtract the powers. 56 divided by 2 is going to be 28. And then the b's cancel. So now let's look at this inside trinomial. Does it follow the rules that we discussed, or the structure? Is the middle exponent half of the original in the front? Absolutely. So now 4 is half of 8. So now this trinomial is in the same structure that we can use. So we're going to multiply our first term and our last term. So first and last, and we get negative 28 b to the 8th. And I want the factors of negative 28 that are going to add to this middle term of negative 3b to the 4th. So let's start with the factors. So 1 and 28, 2 and 14, 3 and, 3 and nothing, 4 and 7, 5 nothing, 6 nothing, okay, 7. So we're done. But I need to multiply to b to the 8th. So I need a b to the 4th times b to the 4th. And I need a negative 28, so one of the pairs has to be negative. So let's see what pair will add to this negative 3b to the 4th. Too big, not going to work. Negative 4 plus 7. That's actually a positive 3, so if I want to get a negative 3, I just have to switch it. So 4b to the 4th and a negative 7b to the 4th will work. So this is going to be the pair that's going to add. So we're going to bring down our first term, b to the 8th. We're going to bring down our last term, which is negative 28, and I'm going to fill the middle with this 4b to the 4th and negative 7b to the 4th. So plus 4b to the 4th and minus 7b to the 4th. And just like normal, we're going to factor by grouping. Group the first two, group the second two, and bring down the sign in the middle. So I could take out in the first two terms a GCF of b to the 4th, and I do my division, and I'm left with b to the 4th plus 4. And then in my second term, I have a GCF I could take out of 7, negative 7, and I'm left with b to the 4th plus 4. So b to the 4th plus 4 is my GCF, and I'm left with b to the 4th minus 7. So this is my final answer, but don't forget we have that GCF of 2b that we took out from the beginning. So we can go ahead and write that down, and that is my final answer. All right, I think it's time for you guys to try some on your own. So I'd like you to try number 3 and number 4, and then hit resume when you're ready for the explanation. Okay, so for number 3, you had to go straight to multiplying the first term and the last term. So we have 2x to the 4th and negative 12. So that's negative 24x to the 4th. And the pair that added to a negative 5x squared was 8x squared and 3x squared, but a negative 8 and a positive 3. So what I did was I brought down my first term, I brought down my last term, and I filled the middle with negative 8x squared and positive 3x squared. So then I factored by grouping, group the first two, group the second two, and bring down the plus. The GCF was 2x squared. So you were left with x squared minus 4. Second two terms, I took out a GCF of 3, and I'm left with x squared minus 4. So x squared minus 4 and 2x squared plus 3 is my semi-final answer. So if you stopped here, this was kind of a trick problem because you had to recognize that this x squared minus 4 was also dots. So we should have here x plus 2, x minus 2 for dots, and then 2x squared plus 3. So that should be your final answer. All right, so for number 4, same kind of concept. Multiply the first and the last. So 5 times 3 is negative 15x to the 8th. And negative 15x to the 8th, I need a pair that adds to negative 2. So that was 5x to the 4th and 3x to the 4th, but a negative 5 and a positive 3. So I brought down my first term, and I brought down my last, and I filled the middle with negative 5x to the fourth plus 3x to the fourth. And my factor by grouping tells me that I group the first two, group the second two, and bring down the plus. So in the first two terms, I took out of 5x to the fourth, and I'm left with x to the fourth minus 1, because anything divided by itself is 1. And then in my second two terms, I'm left a GCF of 3, and I'm left with x to the fourth minus 1. And then the x to the fourth minus 1 is my GCF, and I'm left with 5x to the fourth plus 3. Now, if you left it like this, you're about 99% right, but same thing as number 3, you needed to factor this piece a little bit more. So this is actually another dots. It's a difference of two perfect squares. This one is x squared minus 1 and x squared plus 1. And then I hate to say it again, but this is also a dots, difference of two squares. So this can be x plus 1, x minus 1. Then I can bring down my x squared plus 1, and I can bring down my 5x to the fourth plus 3. So this is technically my final answer. Whew, I know these two were a little bit tricky, and that's okay. If you stopped here and here, just remember to always look out for dots with these higher order trinomials, or even in this case, a double dots. All right, last but not least are problems 5 and 6. Now, 5 and 6, you should notice, are multivariable trinomials. We have x's and y's, right? And we also have higher orders, right? So the 4s. So are the structures good? 4 and 4 are the outsides. The middles should be half, which they are. Here, 8 and 8, the middles are half. Perfect. So I think we can do these just the same way that we've been doing all of the rest. So I'll do one with you, and then you can try the other one on your own. So I'll do 6 because it looks harder. It looks harder, but it's really not. There is a huge number of 160, so maybe I'm thinking GCF, and they're all even numbers, so I can actually divide them all by 2. So I'm going to do that first. I'm left with x to the 8th minus 11 x to the 4th y to the 4th, and 160 divided by 2 is actually 80. So 80 y to the 8th. So the number is still very large, right? Because 80 is there. So we can go ahead and use the calculator if we wanted to. So we can go ahead and put y equals 80 divided by x and look at the table of values. So if I do that, let's see, because we're going to multiply this times this, right? And that gives me negative 80 x to the 8th y to the 8th. So again, if you put this into your calculator and look at the table of values, I'm going to read off the numbers. So what do we have? 1 and 80, 2 and 40, 3 and anything, no, 4 and yes, 4 and 20, 5 and 16, 6 and anything, no, 7 and no, 8, yep, 8 and 10, 9, no, 10, yes, we've repeated. Okay, so in order to multiply to x to the 8th, we need x to the 4th and y to the 4th, right, for all of these. I'm just running out of space, so I'm not going to write them all the time. But I want to see which one adds to this middle term of negative 11 x to the 4th, y to the 4th. And I look on my list, and I see 5 and 16, and I'm thinking that's going to be my winner, right? Because I want it to add to 11. And I know if I subtract 16 and 5, I get 11. So I'm going to go ahead and write that in there, that I'm going to use this as x to the 4th, y to the 4th, x to the 4th, y to the 4th. And I need to multiply to a negative 80, so let's make the 5 negative and see that that works. So negative 5 plus 16, no, that's going to give me a positive. So we just have to switch it. So we can do 5 x to the 4th, y to the 4th, and negative 16 x to the 4th, y to the 4th. So this one's actually not going to be the pair, but this one. So I'm going to bring down my first term, which is x to the 8th. Bring down my negative 80 y to the 8th, and I'm going to fill the middle with a positive 5x to the 4th y to the 4th minus 16x to the 4th y to the 4th. So I bring down my first two and my second two, and I bring down the middle sign. So I group the first two. My GCF is x to the fourth, and I'm left with x to the fourth plus 5y to the fourth. My GCF out of my second two terms is actually 16, negative 16 y to the fourth. And I'm left with, it looks like x to the fourth, and then plus 5y to the fourth. So these two are my GCFs, and I'm going to go ahead and pull those on the outside, x to the fourth plus 5y to the fourth. And I'm left with these parentheses here, x to the fourth and minus 16 y to the fourth. And we just have to check for dots. This is in fact a difference, and they are both perfect squares. So I can make this x squared minus 4y squared and x squared plus 4y squared. And one more time, this is actually a difference again of two perfect squares. So this is x plus 2y and x minus 2y. And I can go ahead and bring down all my other terms. And then don't forget your GCF that we had from the beginning, which was 2. So all that work, and that is your final answer. All right, so take a minute, try 5 on your own, and then hit resume when you're ready for the answer. Okay, so you multiply the first and the last, and this gives you 7x to the fourth, y to the fourth. And the pair that added to the middle term was actually a negative 1x squared, y squared, and a negative 7x squared, y squared. So bring down the first term, bring down the last term, and fill the middle with the terms that added to a negative 8x squared, y squared. And then just factor by grouping. So these two are my first two terms, second two terms, and bring down the middle sign. The GCF of the first two terms is x squared. Then I'm left with x squared minus y squared. Then my GCF of my second two terms is negative 7y squared. And I'm left with x squared minus y squared. The x squared minus y squared is my GCF, followed by the x squared minus 7y squared. And to be careful, this is my GCF, my dots. So x squared minus y squared is nothing other than x plus y and x minus y. Then I can bring down my x squared minus 7y squared. And that is what your final answer should have been. So don't stress if you got here and you didn't remember dots, but do your best to try to remember that. All right, I know that was a lot for today, so please make sure you're jotting down any questions, and then we'll see you in class tomorrow. All right, have a good night.